Today we're looking at the 2010 Form B AP Statistics exam, and this is problem 6, which should always be the longest of the 6 problems in the free response section. So if we take a look at this question, it's about a real estate agent who's developing a model to estimate prices of houses in a particular city. So she has a random sample of 25 homes, and for each house she records the price and so forth. And what this problem focuses on is whether or not the house has a swimming pool. So if we take a look, for example, at some of the data, look at this first house here. The answer is yes, it does have a swimming pool. We see its square footage. That's how big the inside of the house is. And we see that it's on sale for $274,000. Its residual is +6. So residuals, in case you forgot, are always observed values minus predicted values. Usually write it in shorthand, y minus y hat. You'll notice that some of the houses have negative residuals. So if we look down further, there we go. That one has a negative residual. That one does. That one does. These houses also do not have pools. So what we notice is these houses cost less than we would have predicted. And there's 25 data points. You can see the rest of the table here. Our table's organized in a nice way too, because if you look at it, you'll notice that, let me get my highlighter for you. You'll notice that this first batch of houses here, I'm a little far with that. First batch of houses that I've highlighted have a swimming pool, and then the remainder of them, the ones on the bottom, do not. All right, let's see what else, other information they give us. Turns out they give us a scatter plot. And this is a clever scatter plot. You'll notice there's 2 different types of marks on it. And that's because everything with a square is a house that does not have a swimming pool. So I'll put little red dots on them. All those little dots, there's a whole bunch of them. Those are houses without a swimming pool, according to the key up here. Okay, and then all the houses with a open circle, those are houses with a swimming pool. And then if we look further down, here's a graph of the residuals with both of them superimposed. And so when you read these questions, you might start to suspect what the question might be about. Since this question is giving us a scatter plot where they're emphasizing that there's houses with swimming pools and without, then that leads us to believe that's what they're going to care about. You'll notice that almost all the hollow dots, with the exception of 2 of them, have a positive residual. And so that's telling us that these houses, the actual price they paid, the observed price minus the predicted price, was greater than 0 in most cases. Here, 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 and here, and here. So that might insinuate that having a swimming pool raises the price of the house. And then here we have the linear model to fit with all the data combined. Okay, so it says interpret the slope of the least squared regression line. So you should know how to read information like this. Always go down here to the parameter estimates. The first thing here is the intercept. So there you are. That's your y-intercept right next to it. Underneath that, you'll see the word size. In this case, that's always your explanatory variable. So in every problem, when you get these outputs, I think they come from a program called Minitab. Correct me if I'm wrong. This thing I'm circling here in red, the variable size, would change. If you had a different problem, you had a problem with like test scores and hours studied, then maybe you'd see the word hours here. But next to that is the slope. So here we go. The slope is 0.165. Don't forget y is the price in thousands of the house, and x is the size of the house in square feet. Okay, so what I like to do with slopes, in order to interpret them, I like to write them at sort of like a fraction. I mean, in this case, there's a couple ways you can do it. You could just leave it 0.165 and then just put it over 1. You could put it 165 over 1,000. It's up to you. Don't forget that slope is always change in y over change in x. So if we were looking at this version of the slope, we'd say for every additional 1,000 square feet of size, the price is predicted, and you want to use the word predicted here, to increase by $165,000. So that's an interpretation. If you decide to interpret this way, then just be careful with that 0.165. 0.165 thousands is just, or thousands is just, it's $165 is what it is if you divide that by 1,000. So this would be saying, we would just say for every increase in 1 square foot would lead to $165 increase in price. So that's what that's saying. Okay, that's it. Something like that would be okay. Make sure you use the word predicted. Okay, part B. The second house in the table has a residual of 49. Interpret this residual in the context of the study. So they want to make sure that you know what a residual is. We kind of already talked about that, but just in case you missed it, or you didn't hear my comment earlier, a residual is always your observed value minus predicted, or y minus y hat. So we have a residual of 49. Then that means that this house was, and don't forget y is in thousands, this house was $49,000 more expensive than it had been predicted. And you can see that in the formula because if you look at the first value is observed, so I'm underlining those in purple. And the predicted value is what we're subtracting from that. I'm underlining that in blue. So if you got a positive difference of 49, it means your observed value, those purple values, were higher than the predicted values. Hence, that's what it means. This house was $49,000 more expensive than we had predicted. If we look at the second house, notice there's the residual 49. I'll use red here. There's the residual, oh, sorry, red. There's the residual 49, and yes, it did have a pool. All right, let's keep going. Use the residuals from all 25 houses to estimate how much greater the mean price of a house is with a swimming pool would be on average than the price for a house of the same size without a swimming pool. Okay, so you really have to take an option, a way to handle this. What I would probably do is I would go back to this data in this table. I got a lot of stuff, a lot of busyness here. Let me just delete some of that, get rid of it out of our way. And we're trying to talk about the residuals for houses with pools compared to the residuals for houses without pools, right? That's what we really care. Use the residuals are telling us to look at that. So if we look at this first set of data up here, this whole group of houses, we can look at all of these residuals that are right here, and we can find the average residual, right? So I'm going to call that X bar sub P, meaning the average of the residuals for houses with pools. Now, in the interest of time, I can tell you that if you do that, that you will get about 18.6. And then similarly, if we looked at all the rest of the homes that did not have a swimming pool, so we can look at all these, and we can find the average, I'm going to call that X bar NP for no pool, and that turns out to be about negative 8.8. So you have to take the time to plug all those residuals here into your calculator and find the average. So what we can do now is we can start to answer this question. They told us to use the residuals to predict how much more expensive a house with a pool would be as compared to a house without a pool. So if we were to just subtract these two numbers, we did 18.6 minus negative 8.8, we'd get the average difference in the residual. So let me just do that for you real quick here. 18.6, really you're adding 8.8 to it. You get 27.4. Now you want to write the answer to this correctly. So what you need to say in this question is that based on the residuals, the average price of of a house with a pool is about 27.4K or $27,400 higher. That's what you'd want to say there. So, and I can't really fit the word higher in there, but I'll write it up here. Here you go. So that's the answer to that question. All right. So now, to further investigate the effect of having a swimming pool in a house, the real estate agent creates two regression models. So what you'll notice is there's a regression model. This upper line is for the houses with a pool. That's that blue line. And the lower line, which I'll underline in red, is for the houses without a pool. And sure enough, the blue line looks like it's higher than the red line. So it looks like we have higher prices all along this predicted line. And you can just look at them to see that. The lines do look parallel. If we look over at the actual equations, we'll notice the slope of the first line. Well, let's color code that. That would have been the blue line, so I'll put blue there. Is 0.166, and the slope of the red line is 0.160. Now those slopes are very close together. And keep in mind, these are regression lines. We haven't looked at the price of every home in this area. This is just a sample of homes. So in part D, they say the condition for inference have been checked and verified. A 95% confidence interval, and this is important, read carefully, for the difference in the two slopes is between negative 0.099 and positive 0.001. Based on this interval, do you expect that or do you think that there's a significant difference in the slopes? The answer to this question should be no. And just like in any confidence interval, since it contains 0, that's your reason. 0 is a possible difference between these two slopes. That's what this confidence interval is telling us, that we think the true difference in the two slopes of these two lines up here is somewhere between negative 0.099, that is, and positive 0.001. Since 0 is contained in there, we say we don't have significant or evidence to suggest that the slopes of these lines are different. Okay. That feels a lot like when you compare two proportions. If you do a confidence interval for the difference of two proportions and you get 0 in there, then you say there's not a difference in the proportions. Same thing's true with means. All right. So then finally it says use the regression model for the houses without a swimming pool to estimate how much greater the price for a house with a swimming pool would be without a swimming pool. Okay. How does your estimate compare with the result from part C? Okay, so since we've just shown that these two lines in part D don't have a significantly different slope, then that would mean the vertical distance between them, oops, sorry about that. The vertical distance between them, I could estimate just by finding whatever that vertical distance is. I'm drawing these little green lines in, but that's just the vertical distance between the two y-intercepts, which exist in the equations. So what I can literally do is just subtract them. So if I do, I guess the higher one is negative 11. So negative 11.602 minus negative 27.382. And if we do that, we get a difference of y-intercepts of positive 15.78. In other words, is about 15.78, sorry, about a $15,780 difference if the house has a pool. And so we can say that this difference is a little bit smaller than what we would have predicted just by looking at the residuals. But this is probably a more reasonable estimate because this regression sort of averages out some of the extreme residuals with the others. And also keep in mind that when we look at this graph here, these dots that are on the graph are just a sample of 25 houses. It's not all the homes that are in the area. So that's it. All right, so I hope you enjoyed that. If you have any questions, please write them down in the comments and I will try to answer them. All right, take care. Take care.